Hey, do you know what stoichiometry is?
No. We should probably review that before the exam. Ashley, what is stoichiometry?
Well, guys, it's balanced chemical equations that can be interpreted in terms of representative particles. Atoms, molecules, formula units, and then moles and mass.
That is fascinating.
Okay. This is where it all starts. Moles. Hopefully Dan Zeddy's group, Matt Hiles' group, did a pretty good job of explaining that chapter so you can know how to do stoichiometry. Otherwise, you guys are screwed.
Grams of carbon right here. How many moles of carbon is it?
Well, the problem,
How do you know it's going to be, Jason?
because you're going from moles to mass, which is one step actually. So it's even simpler than I thought. Stoichiometry is easy. So you put this in your given, and then I want to know how many grams, because that way it will cancel out in the end, because you're multiplying these, of carbon there is in 1 mole of carbon. Actually, how many grams are in a mole of carbon?
Well, according to the periodic table, there are 12.01.
We'll call it 12 for simplicity's sake, in 1 mole. So you multiply the top across, divide it, which is 47 times 1, which gives you 47, divided by the bottom across, which is 12 by itself, and that's about 3.9. So Joe, in this thing right here, you have about 3.9 moles of carbon. There you go.
Don't forget your units.
Oh, yes, you're in moles.
Yeah.
That number has to do with step number 2. 2 on the mole map. Number is 6.022 times 10 to the 23rd power. So you multiply however many moles you have times that, and that gives you how many atoms you have. Now let's do a practice problem.
Now, Ashley, I have 1 mole of carbon, and I'm just curious to know how many atoms of carbon or whatever that would be.
Well, Joe, it's pretty simple. It's a one-step problem. You have to put 1 mole of carbon on top, and then, since it's the same unit, you have to put it on the bottom down here. And then you put that number that we said before up here.
Avogadro's number.
There you go.
Good man.
And then that is going to be converted into atoms. And then these units cancel out. And once you do pretty complicated math right here, it's going to end up being 6.022 times 10 to the 23rd atoms
Don't forget your units, people.
of
They're
carbon.
important. As you can see, this looks like you were studying earlier, plus a little bit, because if you got a molecule that's a collection of more than one kind of particle together, like H2O, you have to multiply that out to get your atoms, which was covered in the moles chapter today in Zeddy's. So you better get on that. And then, if you have 2 chemicals that you want to figure out the relations between one another, pretty simple. You just have to cross this line right here, and it's a flip of the map. So you can go from moles to moles, and then from there you can go from wherever you want. So you can go from all the way over here to all the way over here. Simple stoichiometry. Okay, here we have an equation with 2 reactants and 2 products. We have the question of how much of this product, Na3PO4, can be produced. So what you have to do is do your stoichiometry for each of the reactants to see how much it would produce for it. Now this one produced 36.7 grams. The Na2CO3 produced that much. And the Ca3PO4 produced 92.2 grams. Now, there's not enough Na2CO3 to produce 92 grams. There's only enough to produce 36.7 grams. So therefore, this is your limiting reactant because that's all you can produce. And this is your excess because you have more than you need to produce what you're going to produce of your final product.
And going back to our map that we used before, the moles can be determined from the coefficients that are in the equation, and that is just stated between converting one mole to the other, and then that just determines the answer.
Okay. Stoichiometry, there's two kinds of yields you get in your problems. Theoretical yield is how much when you do your problem on paper and doing your math you think you're supposed to get, and actual yield is when you do the actual experiment how much you think you're going to get. Now, using these two, there's a few different things you can figure out about your experiment to test your accuracy. If you do your actual yield divided by your theoretical yield times 100, that's your percent yield. So that's how much percent of your theoretical versus your actual you were. And then theoretical minus your actual divided by your theoretical equals your percent error, or how much percent you were off. We got theoretical and actual yields from an experiment here. 14 and 15. So we're going to find our percent yield by taking our actual yield over our theoretical yield, dividing those two out, and check my calculator, that's about 91.2%. Bam. That one. That was quick. We'll do another one now.
Real quick.
Error.
That's what she said.
Ooh, you slide, devil. Okay, enough of this tomfoolery. Okay. 15 minus 14 is 1. 1. And then 1 divided by 14 times 100 gives you 8.8%. So there's your percent yield and your percent error, which 8.8 really isn't too bad unless you're dealing with harmful chemicals. Then you possibly could die. But we weren't in this case, so nobody died. And that pretty much stoichiometry started at moles, wound up here. It's been a fun journey, people. Thank you.
Yeah!
Woo!